Hi, I'm Gerardo Zavala and I'm going to present the final results and the demo for the Mechanical Components Classification project from 3D Objects from the Smart Manufacturing course. So here I'm showing the first run that I tried, model version 1, with a learning rate of 0.01. So you can see in here that the first important part is that the training and validation curves look like they are jumping a lot and they are not like smooth as we expected. Another thing that it's important to mention is that I use 20 epochs only because it takes some time to be trained. The model was trained in Google Colab to be able to use GPU. Also, another thing that I did is I reduced the weights of each of the layers of the PointNet architecture because they used a higher weights on each layer, and that gives you like 3 million parameters to train, which it will be taking a lot of more time to train. So you can see in here, this was my first model. I take this as my baseline model. So you can see in here an example of how the model is predicting. You can see that it is getting some predictions correctly, and other ones it is not doing the predictions correctly. The accuracy that I was able to obtain with this first run was 60% of accuracy. This is done on the test set, so it is a good first baseline model. It's better than random guess. So the next thing that I tried is to reduce the learning rate to see if I can get a better smoothing on the curves of the training and training accuracy and validation loss. So you can see in here that the curves look more smooth now, look smoother than before, reducing the learning rate to 0.001. So, and the results are also better. You can see that I have training and validation accuracy above 80%. Also, you can see in here that the validation loss looks smoother. So, with this version 2, I was able to obtain a 98% of accuracy. You can see in here that it is almost predicting everything correctly. You can see that the class, for example, class 54 corresponds to studs, class 9 to conventional rivets, class 41 to screws and bolts with cylindrical head. So these were the two runs that I did, with the consideration that I reduced the weights of each of the layers. So for example, in the future, if you want to try this and have a lot of classes, you can leave the weights of each of the layer from the PointNet architecture. And also maybe you can try more epochs, you can change the batch size, you can try a different learning rate. Remember that if you reduce the learning rate, the model will tend to fit better the data because it is able to get a global minima instead to be trapped in a local minima. So, but the problem with that is that the model can take a lot of time to train, and since we have a lot of images in the training set, that's why I decided to go only with 5 classes, because the training set has 68 classes. Okay, so finally I built a demo that I will show you how it works.